All right, let's jump right in. Today we're tackling adding and subtracting polynomials. And I know that sounds super fancy and maybe a little intimidating, right? But I promise you, it's actually built on a skill you already know pretty well, just combining like terms. Seriously, if you've got that down, you are already most of the way there. So let's do this.
So first off, what even is a polynomial? Don't get thrown by the name. Just think of it like a team of terms. That's all it is. In an expression like, say, 3x squared plus 4x plus 5, each one of those little pieces, the 3x squared, the 4x, and the 5, they're just players on the same team. Simple as that.
Now, the key to working with these teams is finding players with the same jersey. And in math, the jersey is just the variable part. We call these like terms. So 3x squared and 5x squared, totally like terms. They both have that x squared jersey. But look at 3x squared and 4x. Nope, those are unlike terms. They're playing different positions. Our entire game plan from here on out is just to combine the players with matching jerseys.
Okay, so you know every game has rules. Well, for polynomials, there are really just a couple of simple ones we need to master to play like a pro.
Rule number 1 is all about organization. It's called standard form. All this means is that you always write your final answer with the terms in descending order of their power. You start with the highest exponent and just work your way down. It's kind of like lining up your team by position. It just makes everything look clean and makes it way easier to read. And here we have it, the number one trap people fall into with polynomial subtraction. When you see that minus sign sitting in front of a parenthesis, you have to know that little sign is way more powerful than it looks. It's a command telling you to do something to every single term inside. And check this out. That negative sign basically gets distributed and flips every single sign inside the parentheses. The positive 3x squared becomes a negative 3x squared. The negative 4x flips to a positive 4x, and that positive 5 turns into a negative 5. Seriously, just remembering to do this for every term is the secret to avoiding the most common mistake there is.
All right, talk is great, but let's actually see these rules in action. We're going to walk through a few examples, and we'll start with a nice, simple addition problem.
So in this first example, we're just adding two polynomials. The first thing we do is find our like terms. We'll grab the 3x squared from the first team and the 5x squared from the second. Then we'll take the 4x and the negative 2x. Now we just combine them. 3x squares plus 5x squares gives us 8x squares. And 4x minus 2x, well, that leaves us with 2x. Our final answer is 8x squared plus 2x. And hey, look at that. It's already in standard form. Perfect.
Okay, now for subtraction. This is where we have to watch out for that trap. First things first, we distribute that negative. That changes the second polynomial to negative 2y squared minus 4y plus 7. See how all the signs flipped? Now it's just an addition problem. We combine our like terms. 5y squared minus 2y squared is 3y squared. Then negative 3y minus another 4y gets us negative 7y. And finally, 2 plus 7 is 9. So our final answer is 3y squared minus 7y plus 9.
So what happens when some terms just don't have a matching partner? Like in this example, x cubed doesn't have another x cubed term to combine with. Same for the 2x squared, the 5x, and the negative 4. And you know what? That is totally okay. It's not a problem at all. They just stay exactly as they are. Our only job is to put the final team together and write them in standard form, from the highest power down to the lowest. And that gives us x cubed plus 2x squared plus 5x minus 4.
We've kind of seen these in action already, but let's just highlight the two biggest pitfalls one more time. Getting these right is absolutely the key to getting these problems right every time.
Okay, this one is a biggie. When you are adding or subtracting polynomials, the exponents, they do not change. Just think of it this way. If you have one apple plus another apple, you have two apples, right? Not two apples squared. It's the exact same idea here. X squared plus x squared just means you have two x squareds. You only start messing with exponents when you're multiplying, not here. So let's recap those two main traps. First, do not touch the exponents when you're adding or subtracting. Leave them alone. And second, when you subtract, you have to make sure that negative sign does its job on every single term in the second polynomial, not just the first one. Every single one.
So why does any of this actually matter outside of your math homework? Well, it turns out polynomials are used to model all sorts of real-world stuff, especially in business. Let's take a look at a classic example.
You know, every single business runs on this one fundamental formula. Profit equals revenue minus cost. And a lot of the time, the money coming in, that's the revenue, and the money going out, the cost,
can both be described by polynomial functions.
And this is a perfect real-world example of the rules we just learned. To find the profit, we subtract the cost polynomial from the revenue polynomial. And step 1 is absolutely crucial. We distribute that negative. That changes a 2x squared plus 10 into negative 2x squared minus 10. Now we just combine like terms. 10x squared minus 2x squared gives us 8x squared. The 50x, well, it doesn't have a like term, so it just stays. Same for the negative 10. And that leaves us with our final profit polynomial, 8x squared plus 50x minus 10. This is the exact same thing we've been practicing.
So the next time you see a really long, scary-looking polynomial problem, don't get intimidated. This whole entire process really just boils down to two things: combining the terms with matching jerseys and watching your signs. If you can master those two things, you can solve any of these problems, I promise.
Getting this skill down is a huge step. You're building a foundation that is absolutely essential for more advanced stuff down the road. So as you practice this, kind of think ahead a little bit. How is being an expert at combining terms and distributing negatives going to prepare you for something like, say, polynomial long division? Because trust me, it's all connected.